Okay, and let me just grab a link to the minutes so everyone has them. All right, well, I guess the first thing up for today is there's been a lot of stuff happening with FastAI, thanks to Lorenz, and he's going to give us an update on all of that. So take it away.
Yeah, right. I think there's some new people, or at least I don't recognize the names. If there's any questions that come up or any context that's missing, just ask if you feel like it. Yeah, so over the past months, there have been a few packages that have been published, which are now being consolidated into like a high-level, easy-to-use API similar to FastAI, which will be called FastAI.jl when it's published. And I started working on that like 3 weeks ago. I just quickly, if you want to follow the progress, there's a message thread on the Zulip. I send it to the chat if you want to follow it. I'll give updates there when anything new is implemented. Yeah. So the FastAI.jl, it's not a direct copy of the FastAI APIs from Python, because well, I personally feel like in Julia a lot of things can be made nicer, and currently it's mostly a matter of plugging the libraries together. So for one, there's fluxtraining.jl, which gives like a customizable training loop with callback system, similar to the training loop in FastAI. There's data augmentation.jl for creating data augmentation pipelines, especially on images with projections and everything, doing that fast and in place. And there is deep learning pipelines. It's like a high-level interface for defining basically how the data is pre-processed before putting it into the model, and how the model predictions outputs are decoded into actual predictions, and kind of abstracting that. So that way it's really easy to use the high-level API once it's implemented. I think I can't share images here, right? In the chat?
Yeah, I don't think so. That's why I was asking about whether you wanted to share anything to make sure that
can I share my screen, because it's just the image from the Zulip thread.
Yeah, so try sharing your screen, I guess.
Yeah, okay, that works. Can you see it?
Yep.
All right. So for those of you that haven't seen it yet, this is kind of how simple the interface will look like in the end. So really short, similar to FastAI. You import the package, you load the data set, you define basically what kind of task or method you want to train. So here it's an image classification problem. You give the labels, the image input sizes. Then from the data set, you create data loaders that iterate over batches. You have a helper for creating a classification model from a backbone like a ResNet by stacking the classification head on top of it, using the information in the method, which knows how many outputs there should be. And then you can put that into a learner, which is also similar to FastAI. Takes a model, the data, an optimizer, loss function, and then callbacks similarly to FastAI as well, to train on the GPU, to measure additional metrics. And there's more of them in Flex training already. So checkpointing, for example, logging to TensorBoard. There's also been plans to add a logging backend for weights and biases. What else is there? Well, there's some callbacks. Actually, I'll just put a link to the Flex training docs, which so the documentation right now is still distributed across the different packages. Send the link, but the plan is that once can I find the chat? No. Where's Zoom? Okay, but I'll just stop sharing. Okay, here's the chat. This is the link to the Flex training docs. So the plan is that once like a first FastAI.jl version is running, we'll consolidate the docs there because that makes the most sense, and have it as an entry point for new users as well, and have tutorials there on how to use it, but also on how to extend it, how to create your own learning tasks and problems, and make use of the different libraries. Yeah. So yeah, I mean, right now, what do we have? The documentation scaffolding with some simple documentation. It's pushed on my fork of the repo, but I don't think it's clonable yet, because there are also some it's a bit messy. There's also some changes I've had to make in Flex training in the internal APIs. So I think actually that will go together with the FastAI beta release. But yeah, so for now I'm working on, or I've already gotten to work the fit one cycle basically from FastAI, just taking that from the interface. Also the fine tuning with some basic like freezing the backbone for an epoch, and then doing like training with a low learning rate, like exactly the same behavior as in FastAI. The only thing missing right now are the discriminative learning rates, since I think that's more of an optimizer problem. Probably Kyle, we should talk about that at some point, since I think you're more into the optimizers, right?
Yeah, that's on the schedule for later. So, but I guess one thing to add is for the FastAI stuff. I guess the sooner we can have the master branch of the main repo, reflect some of the stuff that you've added. Because I think the master branch right now basically has what we had a year ago, which was, all of Peter's code, didn't use, any of the packages that we've made over the past year. And so having that in on the master branch, one, would be good for people visiting so they can see what it's actually supposed to look like. And then also it would be good for contributors, because I think there are, people interested in contributing pieces here and there. So the sooner we can get things like issues and stuff up and running for that first release, I guess the better.
Yeah, I totally agree. And I'm also almost done with the learning rate finder, and then I wanted to get to cleaning up the dependencies and making it clonable. So while implementing the high level functions from FastAI, I also stumbled on some roadblocks in the way Flex training does some things. Like, not impossible, like it doesn't make it impossible, but also not very straightforward, which, that said, isn't different in FastAI. There's a lot of sometimes hacky stuff going on, or at least it's not sometimes the right abstraction there. For example, the way different training schemes are implemented. I think, I'm not sure if it still does that, but for example, the generative adversarial networks in FastAI, they use control flow to skip the gradient update, and then they swap out the model. And yeah, so I'm also thinking about how to make the flux training, make it more extensible for not very standard supervised learning tasks. So I know that Brian also had an example. Yeah, I think he works on self-supervised learning. And we should probably create a discussion issue on the Flux GitHub community, and yeah, explore some design stuff there. But I think probably a first clonable beta of FastAI doesn't need that yet, since it's working for now.
Yeah, that was my thought as well. Like the more exotic control flows, as long as we have them in mind, I don't think they should hold back getting something out for FastAI. But we can start that discussion.
Yeah. Just to mention that there will be some breaking changes in Flux training in the internal API and the training loop extensions. And yeah, so oh yeah, and one more thing that is in FastAI already is all of the FastAI image classification datasets. They can be downloaded automatically using data labs, and also loaded into a data container that already loads the images and converts the classes. Just need to do the same thing for the other kinds of FastAI datasets. So for those who don't know, there's a 2 years ago, I think, FastAI together with Amazon released like a page where they host common machine learning datasets, and you can just download them there, and they all have a common format, so it makes it really easy to work with them. And those are also used in documentation of FastAI. Yeah, I think that's it for the progress so far. It's still the pre-trained models are still missing. So while the fine-tuning is implemented, you need a pre-trained model to fine-tune.
Yeah, I guess that's like the next set of updates. So good segue. I guess just in the middle there, I have the publish theme on here. I think everyone pretty much who's been following along in Zulip knows about it, but I guess now the theme that's linked in the agenda, we should try to use that as much as possible. And then I think certain packages might have small CSS tweaks they want to make to that. I think that's fine. It's not like we have to all adhere to exactly the same theme all the time, as long as it generally looks Flux-like. That would be good.
Yeah, I agree. I still have to update some of like for the training, I think, which looks almost the same, but
right. And then I guess for the pre-trained models, yeah, so I've been trying to train that for some time now. And I mean, unless someone knows, and there's no guarantee this would work on Flux just because it worked on TensorFlow or PyTorch either. But if someone knows the magic combination of hyperparameters and optimizers or something that makes the model loss converge for pre-training models on ImageNet, I guess send that my way. But as far as I can tell, it doesn't seem like the loss is actually going down. And I mean, in my opinion, it's not worth, waiting two weeks to find out that something hasn't trained at all. So, yeah, I mean,
for these?
the ones in Metalhead. So these are just the update to get the. I can link to the PR.
Is this like a very vanilla ResNext, RetnaNet all? Oh, I
Yeah,
don't think we have RetnaNet on Metalhead.
I mean, right now it's I'm specifically trying AlexNet, but
Oh,
I mean, it could. All of those are included. Here's the link to the PR. So, I mean, the main reason for, so this does affect, downstream stuff like FastAI, because, like Lorenz was just saying, we need these pre-trained models in order to do some of the tutorials that are there in the FastAI documentation. And so I guess this PR is blocking a lot of stuff, but I think the general consensus is that we don't want to merge a PR that doesn't include all the functionality that was there in the repo before, right? So there were just a handful of models in the repo before. I think ResNet 50, maybe some of the VGGs, and one of the DenseNets that had pre-trained weights. We want to provide at least that set of pre-trained weights before merging the PR. But yeah, like I was saying, it's kind of a toss-up, trying to pre-train all these models. There's no guarantee that the same set of parameters is going to actually train any of these models either, or like train the same models with the same set of parameters. So I guess I'm kind of looking at how much effort doing something like ONNX to Flux would actually end up being. Initially, I wanted to just go ahead and train the models and just be done with it. And the reason for that is because it requires the least manpower, right? You can just hit train, leave it for like a week or two and come back and commit the weights. But if the model isn't converging, then that ends up requiring a bunch of manpower to get it to converge, at which point we might as well just use the weights from somewhere else.
Right.
Yeah.
So some comments from the FastAI side and for documentation and pre-training for newcomers. I think it would be great to have at least one common model, like ResNet 18, that's easy to train on a single GPU. And probably the simplest way is to convert it from ONNX.
so that
I do
wouldn't
still think
necessarily
that.
work.
Sorry?
That wouldn't necessarily work. Yeah.
But is that what was done for the Metalhead models in the first place?
Yeah, so we had taken pre-trained weights and then trained them further using vanilla Flux. That is how we got the weights that we do have right now. But one thing that we noted really early on was that if you were to use those weights directly, we almost always end up diverging. I don't know why exactly, but I guess there were a couple of students who were able to figure out, well, certain things need to be transposed just so, and then everything was converging fine. But initially, we had to, use those weights and then train again.
Other than
Yeah.
ensuring the dimensionalities line up, is there anything else that's mismatched between? There shouldn't be, right? Because eventually it should all go down to cuDNN anyways, for the most part.
Right. The
Right.
lowest level of parameters, other than things like transposing and reordering the dimension, should all match up. I mean, it's the higher level structure that would be different, right? Now, the old
Yeah, I
metalhead,
think
I think, matched the higher order structure of PyTorch, but this
so.
metalhead wouldn't. So there'll be some translation in there that I was hoping
Right.
to avoid, but it seems like it's just better to just do the translation. It's less effort.
I'm not sure if I can find it still, but we did have a script that would load PyTorch and TensorFlow weights into regular chains. And
Yeah, that would
that's
be
what
really
we end up
helpful.
creating ultimately anyway, right? Like, regardless of what kind of structure we're dealing with.
So, but what I was wondering is, what I was saying is just having the pre-trained models that are already in Metalhead right now, making them available. Maybe it's even possible to have them available in Metalhead and have the new, more Flux-like implementations. So maybe just have them as artifacts or something until we can replace them with ones we actually trained in Julia. So we can use those in the documentation and fine-tuning tutorials. And then I also think that actually training a model on ImageNet in Julia would be a great, proof of concept that it's actually working. And since Kyle asked what the exact parameters are, I just recall that that Jeremy Howard entered, I think, in the Dawn Bench competition, where basically you try to train a model on ImageNet to a certain accuracy the fastest. And maybe that could be a good starting point for hyperparameters. And then also, I think he used stuff like progressive resizing. So he starts the training with low image input size and then progressively increases that when he gets closer to converging. And those kind of things, those training tweaks, actually using FastAI for that and the ecosystem, I think would be a great proof of concept.
Yeah,
Just
I
one more
agree.
oh, sorry, go
bro.
ahead.
No, go
Just
ahead.
one more thought on loading weights. So in theory, the high-level structure of the new middlehead model should be the same as the old one, right? Is it not possible to load the weights, the old BSON weights, into the new chain-based models?
Yeah, I mean, well,
And
I
then
guess
just save that as a new artifact?
yeah, I guess that would actually definitely be the easiest. Yeah,
You
let me
would
try that
probably
then.
want to, just a word of caution, you would probably want to verify that because those are pretty old at this point.
The
Do you
weights, you
mean
mean?
like the weights or the model structure?
The weights when it was trained, right? So like, not necessarily sure whether the forward passes were, matched 100% at the time when we did the original training, right? So maybe we can use them to fine tune. That helps.
Yeah, I mean, that's what I was thinking. If the performance wasn't, up to par, but yeah, I mean, it should just be a question of taking those, bottleneck or whatever the name of the structure might be and translating it into skip connection or whatever it's supposed to be. And the rest of it should just be a chain. So yeah.
And even I feel like as an experiment, it would be faster than trying to wait 14 days on AlexNet ImageNet training, which is a little crazy.
Yeah, I agree.
Just a quick question, I guess. So we did try to do some work on Dawn as well, but are you sure that all the hyperparameters and such are available in an easy to parse place, or will we have to like search through a bunch of places, I guess? Because if I recall
I'm
correctly, a
not
couple years ago,
sure.
it wasn't mandatory to actually even reveal your source.
Yeah,
Or at
I'm
least
not
openly.
sure, but I mean, I just remembered. I mean, I figured. I mean, he was talking about some things that they used, and then again, I think it was also heavily like multi GPU, and it involved scheduling on AWS Spot instances to make it cheap, right? Which are different things, but so no, I'm not sure. But given that most of the stuff FastAI does is public, you can probably find those somewhere, or at least find since I think last year also while working on the course, Jeremy got really good results on ImageNet, which must be public. I think somewhere there's code at least, which should well, hyperparameters which do converge and also take into account training time, and try to not just be Google and throw 100 GPUs at it.
Yeah, I mean, on that front, the whole running a script through with ImageNet is both a good test of the ecosystem packages. If we want for like the smaller models like ResNet 18 or something. For the larger models, I mean, it would also be a good test of the data parallel stuff. I don't think there's an example out there of how to use PMAP to do data parallel in Flux. And at least right now, the implementation that I tried on the first pass is having out of memory errors with CUDA. So, at some point, we should circle back to it and get something that works and then actually publish it online somewhere so that people have that as a tutorial and example.
Yeah, that could be in the FastAI.jl docs. So it would be great to consolidate stuff there.
So one thing that I would suggest heavily is that rather than putting everything in the FastAI docs, you probably want it on the Flux page itself, because these things you don't really want to make very difficult to find.
Actually, I think more newcomers would come, especially those coming from Python FastAI, would come to the FastAI documentation.
Yeah, I mean, I think it depends on what the docs are going to end up, or like what that particular tutorial is about, right? I mean, if it involves mechanisms from FastAI, then yeah, I think the FastAI docs will be, I guess, in terms of content or in terms of purpose, quite similar to the Python version of FastAI, which means that there will be a lot of tutorials that are beginner friendly for how to use FastAI.jl to do, standard tasks. Now, the one issue is that we don't have a setup or a pipeline for data parallel in FastAI.jl as of now. So I think what I was referring to with respect to data parallel would basically be vanilla Flux. I think that does belong in the Flux docs. Once we figure out how to get vanilla Flux to train data parallel and put that in the documentation there, then we can build, the FastAI wrappers on top of that and then put that in the FastAI docs. I mean, I think, the important thing is that it shouldn't matter whether you go to fastai.jl or if you go to Flux. If you want to know how to do something, how to do data parallel training, and the methods to do that exist in both packages, then it shouldn't matter where the user goes. They should just be able to find the docs wherever they end up.
Yeah, I agree.
For whatever it's worth, we are working on a couple of projects on the side as well. So this kind of segues from data parallel not just multiprocessing, but also CUDA will soon be able to have some sort of so it'll be able to handle its own scheduler almost, essentially saying that you'll have an entire stream which you can dedicate towards your data management. So that way you will be able to get a lot of the parallel data parallel work going in almost for free. So that's something that we're working on the side as well. I think Tim will be merging that into master soon, and post that, I was hoping that we'll be able to put out a tutorial as well, because we've already seen that like locally we've been able to make it work without doing much change at all. So putting a nice concise tutorial with that would be on the cards. Another is that we're working on like a benchmarking suite. So for that, we would effectively require a bunch of these models. Pre-trained or not really doesn't matter, because if you're benchmarking just like the forward passes and the backward passes and such, then we only really care about long-term trends. But we'll have like a pretty solid way to figure out, how we're progressing performance-wise. So
That sounds really cool.
and I'm sorry.
The work on the GPU scheduler, is there anything public where you can read more about that?
Yeah, I believe there is a PR. Let me
I think
find
there's a
that really
PR on
quickly.
CUDA.
Mm-hmm.
I think it's already, I thought it already got merged.
Yeah, I think it was.
I think I found it.
662. Yeah.
Yeah.
Mm-hmm.
So, I mean, something like this, I guess maybe we should open an issue on CUDA.jl about it. Because CUDA does provide an iterator called CUIterator. It would be really nice to, right now it's something that's, pretty simple. And it's mostly just in there for memory manage or like garbage collection, but it would be nice to combine that with this so that that iterator had a global thread that was fetching fetching batches in the background, onto the GPU so that they're ready when they're needed, instead of having to wait for that transfer.
Also, this is significantly different from CUIterator, in fact, because the job of CUIterator was basically to say, okay, I have, a bunch of data that I want to put into this buffer, whereas this is more hooking into Julia's task-based, multitask system entirely. So that means that we can actually write pre-processing steps on one GPU, make them transfer to a buffer on the other GPU ready to be trained. So that is another one of those things that we were thinking that kind of makes it frees up the space for actual training rather than pre-processing and such. So for OOM kinds of errors, it's a bit better. However, it doesn't really allow us to train much bigger models necessarily, or at least much higher batch sizes for that matter.
So are you saying that because this uses the Julia task-based APIs, for distributed stuff, that the transfer of the data to, a downstream function would happen, in the background automatically? Or I guess basically what you're saying is you don't need to make a version of QIterator that uses this or something like this, that the task system within Julia will actually handle that transfer for us.
Yeah, so right now the system was a bit different, right? Basically, if we had a buffer, all we were really doing was we were committing to that buffer. Right now, the idea is that you have raw data that you're going to be putting into this task system, which will also have its own buffer, but it can also do things like pre-processing in the background.
I see what you mean. Yeah, and I guess to answer Brian's question in the chat about all reduce, I mean, yeah, I agree with Brian. Most data parallel implementations out there have some MPI or nickel backed all reduce operation, and we don't have that, which is, I would imagine, a problem for data parallel, though I guess there's some disagreement about that on Zulip. But yeah, I think if we want to match the performance of other frameworks, we probably would end up needing something like that.
Yeah, I understand the disagreement because that's for, I think it was Chris was talking about, for small or relatively small models, or for models that aren't trivially parallelizable. But for an ImageNet model, like there's no way to get away from this. And I think there's a binary builder PR out for CUDA-aware MPI. There is a nickel.jl repo, but it's long since unmaintained. So I don't know if there's really a good way to do from scratch training at scale without this. Yeah. Not that we really need. I mean, FastAI isn't really designed for a lot of data parallel workloads. Like Jeremy's not a big fan, as I understand it. And generally they try to make everything work with a single GPU. But for making pre-trained models and such, I mean, it's kind of, you still need it, so.
Yeah, I mean, I don't think it's necessarily a item on the FastAI timeline, but I think for the Flux timeline as a whole is like a pretty important chunk that we're missing, something that a lot of people do look for.
I mean, yes and no, right? Because for significantly, yeah, like as Julian mentioned, data parallelism is one way of looking at it, but task-based parallelism also lets you do that, because with task-based parallelism, Julia.jl, you can actually access multiple GPUs and communicate between them. That is
How do
definitely a
you
thing.
communicate between them, though? That's the question. Like, what is the communication medium? Like, can you do device-to-device copies? That's really the big thing. Like, if you can do device-to-device copies and sums between two different GPUs, then essentially you have all you need for data parallel. As far as I know right now, that's not possible.
I think device-to-device copies is a thing. Julian can maybe correct me in that.
Yeah, Valentine is working on UCX support in Julia, which will give you essentially what you get with CUDA MPI, which I believe CUDA MPI is actually implemented over UCX. So,
Right.
and we're then going to implement support for UCX.jl in Dagger. So you'd be able to do task parallel work, but then exchange information between running tasks directly between GPUs. We'll have to figure out like how that works with Dagger's API, but that's something that we're planning on doing, because we need that for various HPC workloads.
Right, and then you'd make all reduce as an abstraction on top of the UCX, I guess. Does UCX only do point to point? I looked through it, but I didn't really understand what it has out of the box.
I'm not really sure, but I know OpenMPI is implemented on top of UCX, so I imagine it supports whatever OpenMPI supports.
Right, and
it's
then
just
UCX
at a lower level.
Right, and then you can grab UCX through binary builder too, so that's nice. No need for, I guess, a separate MPI. Okay, cool.
I'll also say that
good.
for small problems, you definitely don't want to have to set up MPI because that's a pain, especially when you don't have a huge cluster.
MPI not working well for the REPL is also, I feel like that's kind of problematic too. Especially if we're encouraging people to use notebooks or some sort of interactive development. I mean, that's more of the Python FastAI model, not necessarily something that we've talked about here. But I can imagine people would get very confused if they try to use any sort of distributed computation on GPU with MPI, and then you get a bunch of messages about why the REPL doesn't work, et cetera, et cetera.
Yeah, all that sounds cool. I guess, Julian, do you know what the timeline looks like on that?
I'm not sure how soon we're going to get that working, but I know Valentine did let me know yesterday that UCX.jl is ready to go to start doing that integration. So it's just a matter of how quickly we can actually get GPU to GPU working. And like an example, we have grants going right now that essentially require this, so it's definitely like one of the top things that we're working on. I would guess probably 3 months tops before you have something workable. Yeah, but I don't really want to like make a guarantee that it will show up anytime soon.
Right. Yeah, I mean, I guess even for the Flux packages, then they'll be, I guess if we do end up using Dagger or whatever to express the computation, then there'll still be another wrapper that we'd have to build on top of that to make it easy for Flux users. But yeah, that's all further down the road, and I think, like Lorenz mentioned, it's not really necessarily blocking for any of the FastAI work. Yeah, unless someone had anything more on that topic, I guess we can move on to the last one since we're nearing the end of our time.
I guess the last thought that I would have on that is that it's once you get to MPI and such, you're also in a significantly more niche area where sort of the ML effects start to top out, and we start to see more HPC kinds of effects come into the picture. So we can probably leverage a bunch of that pedigree as well.
Yeah, I agree.
So I don't think it's too bad. As long as we can figure out, working with one and getting our memory in control and performance of that matter. Yeah.
All right. Yeah, no, I was just going to move on to the next topic, but I agree with what you said. Yeah, I guess the last thing is the optimizers .jl stuff here. I mean, I mostly added this on here just to, to just give an update. But the link to the PR is in the agenda, but let me see, I can quickly grab it. but I mean, so this PR, I guess, basically just finishes moving over all the optimizers into optimizers.jl. And I think the main thing that'll gain us is that the state will be explicit, which will make doing things like scheduling a lot easier, because now if you want to wrap up a scheduler and an optimizer together, the state of that composed wrapper is the state of the scheduler, which is the iteration count, and then or epoch count, whatever, and the state of the optimizer itself, right? And so having explicit state makes it really easy to put these pieces together, these wrapped pieces together, and hand each piece the state that it's supposed to get, and then update the state accordingly. And so yeah, I mean, I guess I wrote demo on here. I mean, there's not really much to demo, but I guess in terms of like an API, I mean, this is basically kind of what it would look like here to, create a schedule where you want to schedule a learning rate, or you can schedule some other parameter. I guess the only concern I have with the approach that we're going for right now is that because the optimizers are immutable, the scheduler will basically return a new or reinitialized optimizer each time it steps the schedule. So I guess my concern with that is that there's no data structure that you can really access that tells you the current the current learning rate, right? Before you could just like index the optimizer and say, oh, I want opt.eta, and it would print out the learning rate. But there's no way to do that with this immutable optimizer framework. Maybe that's not really that big of an issue, and there's ways to work around it.
Sorry, Kyle, can't you still do that since you just get the optimizer object back? Like you can't change the learning rate, but you can still access it.
Well, I guess it all depends. I mean, you don't technically need to store that object, right? Because every time you call apply on the optimizer, right, or you call apply on the scheduler in this case, right, it's going to reinitialize the optimizer based on whatever the schedule value is, and then call apply on that optimizer, and then on the very next iteration you have a new optimizer. So there's no real yeah, we can store the optimizer. I mean, we don't need to, but we can.
Oh, does the scheduler, sorry, so the scheduler itself doesn't actually store the optimizer.
Right. I mean,
oh, I see. Okay.
Yeah, the scheduler stores the schedule, and this is not the optimizer, but really a function that returns to you the optimizer with the correct parameter value. So, I mean, of course, we can also store the actual optimizer, but that's just, I mean, at that point, you basically have the same situation with the whole update function stuff going on.
So one thing, I guess this isn't part of the PR though, right? Because
yeah, it's not part of the PR. This is just a random fork that I have that uses the PR, but it's not part of it at all. It's just me
sure.
playing around.
I mean, we would definitely want to not have a very strict hierarchy. Actually, now that you mentioned the PR, maybe we can talk about a couple of things.
Yeah.
So one is that Okay, if I can just open it myself. Yep. We should we possibly, yeah, the new states thing. I feel for the sequence optimizer, I'm still not convinced of the name personally. Uh, hmm.
I mean,
But sorry, go
uh,
ahead.
I have no, I guess, strong ties to the very particular name sequence optimizer. I just don't like the name optimizer because, I mean, if you call the sequence optimizer is a bunch of optimizers composed together, and the way that they're composed is sequentially. So if you have something that's just called optimizer that does that, then you're kind of making an implicit assumption that the only possible way to compose optimizers is sequentially. Which I'll admit that none of the other, frameworks for composable optimizers like Optax have anything other than sequential composition right now. But I mean, I guess the name just the name optimizer alone doesn't really tell you anything about what the thing does. But so I'm open to whatever name anyone wants to call it. I just picked sequence optimizer, but it could be anything. Just something other than optimizer is what I would encourage.
How about, I mean, while we're bike shedding, how about sequenced?
That's what I had. I had sequence without the D, but I like sequenced. But I think the reason we kind of went away from that is that it was, I guess, too generic. And I actually ran into a problem with the fact that it was too generic already, because in the original version of that PR, it was called just sequence. And there's also a type of schedule that's called sequence. And so in both of those cases, the name sequence made sense, but, the name would conflict. So I guess, to Daria's point, it does make more sense to have something a little more specific than just sequence, because that's too generic.
Another question, another perhaps harebrained idea would be, why not just make chain work to chain optimizers as well? Chain
So
doesn't.
that is something that we had thought of earlier. So just make a method of chain which, if given optimizers, would do this thing. One basic oddity about that is that it kind of muddies the pretty well established nature of what chain does. I was thinking that maybe saying chain optimizer would be all right.
I'm okay with chain optimizer.
Mhm.
Yeah, I mean, I kind of agree about, I mean, it would be really cool if the chain that you use for layers could also be used for optimizers.
It definitely
But
could. Like, there's no reason why it couldn't.
yeah, I mean, I guess to a certain extent, I don't know in what situation you would ever differentiate through the optimizer, but I guess at least semantically the stuff would be there. Now maybe things would break down for other various reasons. Because at least that was my concern, is that there's a lot of functionality associated with the name chain. And I don't know that that functionality is agnostic of what's inside the chain, right? We're kind of assuming that the thing is that it's inside the chain is something that's layer-like. It
Yeah,
could
I
just
mean,
be an anonymous function or something, but it's still layer-like.
Yeah, I guess the contract is it has to be callable.
Right.
But even then, I mean, I don't know if this is really a good idea. One precedent, if you want to look at that, is that PyTorch, for example, lets you compose transformations, like augmentations, in a sequential, and that's actually how they recommend doing it for scripting. So, I mean, is it conflating what sequential does? I mean, absolutely. Does it make more sense than having a separate compose for augmentations? I don't know, but at least like we're not the only ones who have thought of this.
Right.
Yeah, definitely. Uh, but so okay, the status of optimizers.jl as I see it right now is also an area for us to figure out different approaches that we want to take. So for example, the question about mutability versus immutability, the question of explicit state, all of these things are things that we had tried early on. So the only reason that we did not release the package much sooner is because we were not sure about um, how much more benefit we would get. So explicit state was something that we always knew we wanted, but then we also had this want to decouple the optimizers, but then we also wanted chain to just work. And on some level, I feel the problem was it muddied the intent again of what chain is. And as you say, like um, callable was the contract, right, with chain. So
Mm-hmm.
that checks out.
Yeah.
But yeah, I don't know. It sort of uh, for a newcomer, it's a bit odd. I would like being told that you have a model of layers, which is something that you're probably very used to, and then saying that you have a model of optimizers. Who knows?
Yeah, I
Yeah.
mean, I think it's fine to play it safe and not try to fit too much into one basket, too many eggs into one basket with chain.
Yeah.
I mean, one thing that we could always do, which might be, I don't know, you'll have to tell me whether this makes sense or not, is to not expose any sort of chain or chain optimizer. Like make some struct like that, but keep it private and only expose one function or override the compose operator so that you have to use that to string optimizers together. And then if we want to change the private struct representation, then we can do so. But that would
That's
be
something
going
that we've
down the
usually
optax
shied away
route.
from. Yeah, that's something that we've always shied away from, honestly. So, even when bringing in schedulers, I don't really want to think of them as schedulers. I want to think of them as, very generic um, containers of some parameters that work on, in this case, optimizers, but who knows? So
Yeah.
something that a struct can change, right? So I would expect a scheduler to also be able to, change things in a regular layer, like a convolutional layer or something like that. So I want it to be generic because that's the philosophy that we've taken with Flux and have been, I want to say, fairly successful with. So yeah,
Yeah. I mean, I think I agree with that. Um, uh, yeah, I also don't know how I feel necessarily about overriding compose. It would look really cool, but I'm not sure how much benefit that we'd actually get in the end, because you're not actually. Yeah, I don't know. Yeah, I think it's like one of those things that's like, oh, we have this Unicode character and it looks cool. but yeah. Other than that, I don't know what it really adds.
At best, it's a nice to have aesthetics thing, so I don't think it should hang up any discussion about the optimizer's PR.
Right, right. Okay, well, I guess we're at time. So did anyone have any last minute things that they wanted to bring up? Okay, I guess if not, everyone, thanks for coming, and we'll see you in 2 weeks. Bye.
Bye.